work? Yeah?
Yeah.
Word.
Amazing.
All right. So give me a second while I set up technology. I'll share screen on Zoom.
Yes, please. Oh, what's that?
Me?
No.
Ooh, that's cool as all get out.
Cool, right? No extra charge.
Cool.
Go with it.
All right, so I'm going to give a speech today that somehow connects drones to build systems. Work wanted me to share something I'm passionate about outside of work and relate it back, so that's what I've done. This first slide here, these images are actually the build output artifacts. All of this stuff is actually designed that this dimensionality allows it to build 3D shapes from 2D images.
It's slightly important. Hang on.
Oh, you're going to plug it in even? It worked. All right, what is Ziprecruiter? They told me to say this. So Ziprecruiter actually connects millions of people every day with their next opportunity. We are a two-sided marketplace that connects employers and job seekers. We both look to make the employer want to pay us money and make the job seeker want to use us for their products. We've got billions of folks on this thing. This site in particular is Ziprecruiter's R&D Israel site. A lot of the people who work here are data scientists. I work on what's called our core team and support all the data they shuttle around. We're doing petabytes a month of stuff and training models and all this other stuff. So it's very fun work. 110 people in this office, fairly large. Focus, like I said, 30% of the people in here are women, which is nice. It's actually fairly well represented. So we're going to talk a little bit today about Kubernetes, build executors, and the idea of moving off of Jenkins. But to get started with it, a wonderful inflation joke that's been repurposed again for Kubernetes endless updates. Every single time you get to the next version, a new one's out. And we want to talk a little bit about how that kind of relates back to what we do every single day here at Ziprecruiter and production incidents, because they're very related. So this is a production incident I had at my own home. I live out in the Arizona desert. My AC died about 2 weeks ago. It was 42 degrees Celsius that day and very shitty. Because of current coronavirus wonderfulness, no one could send anyone out to actually check the size of our roof. So I couldn't get bids from anyone initially. What I went ahead and did, so this is them actually installing and removing the old AC. So this is some drone footage I took just so you have an idea of what's going on with my actual home. But fundamentally, I used this drone to take a series of photos to generate a 3D model and then send that off to a series of companies to bid on the work for my roof. It worked wonderfully. I got an AC installed the following day. So all of that was great. It was still like $20,000, which sucks, but it's better than, you know, dying from heat stroke. So one of the interesting things is in Arizona, all of your ACs actually sit on your roof. So they have to bring cranes up and take everything on and off instead of on the floor. No idea why. It's just a choice they seem to have made. Oh, interesting. It just restarts that when I hit next. Okay, so we're using an open source software suite here called WebODMS. WebODMS is a Python application that lets you upload a series of images with GPS data and camera angle data and generate 3D output. So the way this worked is you take your drone up, you bring the camera straight down, you take about 125 photos. They must have a large amount of overlap so that it's capable of figuring out what all the models are. Each photo includes a whole bunch of metadata that you normally don't interact with. That metadata is what they use to create this 3D model in the end. Now, when you take it, the idea is to take these shots in very careful rows. If you look at this image here, you see this highlighted box area. That's the actual images that I took overlaid on the Google Maps layout. So you can actually see where everything was. In the end, we created this wonderful 3D model. This 3D model is what I ended up shipping to various people for them to give us quotes. One of the things that they have to do for your house when they figure out what size AC is look at the square footage, the layouts, the windows, all this other stuff. So this model was actually necessary for them to determine the correct size of AC and the correct placement. So incredibly useful. What that brings us all to is the idea of builds and build systems. What you do with this tool is you introduce a series of photos, you hit build, and then it generates an output. For me, that's indifferent from a commit to your main source network, right? If someone introduces a series of files, you generate a new image generally, and we deploy the image somewhere, right? Standard development work. Here, we have a massive mono repo, and almost everyone works out of the same huge code base. It's 4 gigs of just source. It's insane. And so the Git operations take forever, builds take forever, and there's just a whole bunch of issues. Like almost everyone here, we were using Jenkins. Pretty much state of the art about 10 years ago when they figured it out for the first time. You got a simple sort of setup here. We have a user pushing a change up to our SCM, source code management, GitLab here. Jenkins then sees some new code changes. It loads a Groovy file. It pushes the Groovy file context into an executor. The executor runs everything, sharing the same disk space and operating space as another set of running executors. And then it reports it back. And then it's a mess. It's standard build systems that we're all kind of used to, where there's a whole bunch of circular dependencies that aren't easy to work out. When a dev tries to figure out what's going on, they're like, wait, how does this even launch? And so it's not super straightforward, okay? What we wanted to do was fix the things that we're seeing all the time. Executors are the single biggest source of pain for me as an SRE. The number of times they'll do random things, or someone will run a job where they're like, hey, I'm just going to delete all the images on my executor, and they'll end up clearing out the cache for everyone, and now builds take 20 minutes instead of 20 seconds because it's just the worst. And it's shared space. It's not legitimately like reproducible build environments that are hermetic. It's a shared computer that people are running on. We frequently have to change the number of executors that can run on a single executor so that the images work more correctly. It's just a pain, right? The next part of it is that Jenkins conflates UI configuration with code configuration. And so there's many things you can't set as configuration in the code, and you have to do manually in the UI. And once you figure out what XML gets updated by the change, you then have to, it's ridiculous. We're doing all of these hacks to just make it work relatively simply. So the next issue you really have with Jenkins is that the executor management and master setup was like pre-Kubernetes, and it's pretty clear that the ideas were like sort of thought about, but never really fleshed out. And that's unreproducible failures. If you rerun a build, it will succeed sometimes and fail sometimes, just really hard to understand stuff. And then with Jenkins, the logic for load balancing across the executors is horrendous. It won't figure out what it should be doing. It won't do anything. You can add plugins that fix it, but they're terrible and not well supported. It's just a mess. The next big issue we have with Jenkins is every single time you push up a job, it runs a Groovy file. A Groovy file is a horrendous language that's almost impossible to understand, with a whole bunch of native things that barely work, right? Like there's this finally block at the end where you're supposed to be able to catch errors that doesn't work sometimes. There's no way for you to see if your Groovy file will compile without pushing 1,000 changes off to Jenkins and then seeing if Jenkins will run it. So it's like the primary cause of having 1,000 commits that all say the same thing. It's just like trying to figure out Groovy. 1,000.
Yeah, I have a trick for you if you want. You can copy paste through the box. There's like a text box where you can put there the Jenkins Groovy, and then it will show you if it's the file or not.
Oh, I know, but copying and pasting into a text area in a UI is even worse than writing a new commit, right? Like as long as I write a commit and push it, everything just works. I don't have to open up Jenkins. I don't have to log in. I don't have, right? It's the worst. You're right. There are ways to do it. The only way to test a Groovy file is to build an extension that connects to your Jenkins instance and pushes it off to your Jenkins instance to try and run it. And even that's not right because the job can be configured differently based on the source code. It's just a mess. The failure modes for the Jenkins executors are not obvious. It's hard to reproduce a failure. It's hard to debug what's going on. And if you do anything other than like a one-to-one executor, like job running management thing, it's just a mess. And then the configuration of job runs, like you're saying, can mutate randomly. People can go into the UI and change the Groovy file, and it's different from what's persistent. It was a solution that made a lot of sense 10 years ago, and there's been a lot of progress in the field outside of it, right? So finally, our big issue is our build parallelism. Really, these executors just aren't designed to run thousands of Docker things at the same time that only remove certain layers and all this other stuff. You do this complex management where every time you want to clean up after yourself, you have to see what's on the executor, make a choice about what you might have added, and then it's just. And so the other thing is the sharing disk space, and Jenkins will occasionally just, delete stuff in your temp directory for you while a job's running that depends on it and not tell you why it did it. And it's just, I don't feel like I have to explain it much further. Finally, the UI. The UI for Jenkins is not the best. If you want to go somewhere and see the console output, there's 18 ways to do it, right? Each one of them takes longer than the last one. Or you can open Blue Ocean and wait 45 minutes for it to load the page, right? And then it will try and scroll and like forget what it's doing. And I don't understand how they've done this, but it's literally the worst. So we wanted to move off of all of that stuff. We use Kubernetes for everything in here. And so we decided to build a couple of packages that leverage GitLab CI's Kubernetes executor runner concept. So what that lets us do is, instead of all of that wonderful Jenkins stuff, we could totally change it up. DocWalloper, Jacktar, these are two actual legitimate names for people who could work in naval situations. A DocWalloper is someone who loads a boat, and a Jacktar is a merchant marine. And because it's Kubernetes and everyone loves coming up with horrendous names, here we are. So let's talk a little bit about the new flow for when you make a change. How it works in GitLab now is you push a change up, GitLab literally sees it, puts the code into a container that sits inside of a pod with containers that have fresh Git checkouts that are up to date with the latest. So you don't have to wait for anything, and a whole bunch of other really intelligent design things where it just works and leverages Kubernetes to give you completely hermetic build environments. Okay, so DocWalloper. DocWalloper is our Golang application. Okay, this is the quick build output for it, but basically, oh, wonderful. Basically, we populate an SQSQ. We then call out to the GitLab CI pipeline. That starts up a new job. We handle updating our internal tools and new build URLs. We have this wonderful internal tool called Captain's Log that gives you an output of all the different application builds. One of the issues with GitLab's Kubernetes runner is that it doesn't actually connect one-to-one a job with an MR. And so to achieve that, we update our developer tooling that already exists with a link to the correct place. One of the nice things is that we get real timing metrics from this. I can actually say exactly when I sent a command off to GitLab for it to do its work, how long this feels it took to run, and you get better insight into configurability. We also enjoy that with this, we're able to validate application configuration prior to attempting a build. So if something's completely wrong, we don't even have to spin up a pod to tell you. It'll just be like, hey, you've done goofed, and let you know way before you have to wait for a build or any of that other stuff. And then what's really nice about it is it's nigh on automated out of the box. Because the runners work already and they start up, it's really easy to integrate this. Next is Jacktar. Jacktar is a little more complex. This is our replacement for Groovy files, so I want to spend a little bit of time talking about this. One of the biggest things in Groovy files is that you end up calling a bunch of bins that exist on the executor. We're doing the same thing inside of Jacktar, but because Jacktar is a Go application that runs inside of a known Docker file context, I can actually create a lockdown version relationship between like the version of Builda or Scopio or Podman we're running and the expectations of Jacktar itself. So that allows us to write full unit tests that can reliably know exactly what version we'll get of everything, how it's going to run, everything else. What's really nice about the interface is GitLab CI allows you to pass a couple variables. So Jacktar, because of the mono repo, literally gets a commit and an application. And from that can build an output for you effectively. It can also run all of our internal validation that already exists without calling out to other services and reuse all of our other Go code. A big part of it is that we can use the command Go package to actually modify the executive or the environment in which all of our commands run so that everything is set up correctly. So it makes sure that every single time we run Builda or Scopio or PodPod runs with the same environment in the same place, the same version. It's really nice that we keep track of all of that. Again, with this one, it lets us get per app build time metrics, much more accurate than what we were able to get from Jenkins. This will literally be like, hey, it took me this long to build the image, this long to copy the image, and this long to delete it. And that sort of insight is incredibly valuable to us. Instead of kind of looking at the Jenkins build outputs that change randomly over time, and they're in that little table and you try and keep track of it, very straightforward metrics exported to the Grafana dashboards we already use. So it's a lot easier for us to integrate all of this output. We're also, with this, able to much more effectively read the error messages that we get and then send them back to the users in a much nicer way. Very frequently, when Jenkins fails, people go through the build and they have to scroll through 10,000 lines to try and find where it failed. And then they go to the bottom, it says failure and an above step. And so they have to scroll back. With Jactar, the second you get an error, I can send the log directly to the person. It makes it a lot easier. And we're completely free of Docker, so we don't have to pay them a whole bunch of money. That's surprisingly hard. Builda and Scopio are about half as efficient and take forever to do a lot of their work. So we're trying actively to scale that better, but it's where it's at. All right, so GitLab CI as a UI is so much better. It really does a great job of not wrapping anything or putting any of the like pipeline running decoration, none of that start of stage stuff. It's just terminal output, like if you ran it on your computer. So we found our developers are much more able to read the output and self-service problems. That's huge for us. I'm actually on the primary core team. And so when something breaks, they call me. And so being able to write something that allows them to not call me has been great. One of the other big things about the GitLab CI, I touched on it a bit earlier. The container that holds the source code for us is super important. One of the longest times in all of our checkouts was just checking out our code. At 4 gigs, it takes about 60 seconds, even in AWS. Checking it out is just slow. And with the way GitLab has built their pods, the checkout's there, the branch is there, it's already garbage collected and switching over instant. We're seeing about 5-second checkouts instead of 50. And so we're very happy with that speed up. We're also reusing tools that people use every day. I touched on adding something to Captain's Log, navigating to GitLab UI. These things people are all very familiar with and don't require a whole bunch of new teaching. The other nice thing about this is that our build parallelism is now limited by the resources Amazon will allocate to us, not any Jenkins BS. What's really cool about that is that when we want to build a whole bunch of stuff, we don't have to wait on tiered builds. Everything can happen all at once and produce the output that we want, which is phenomenal. Then finally, I don't have to look at that stupid Jenkins logo anymore. I don't know why it logs me so much, but it just pisses me off. So does anyone have any questions about what I presented here?
One question. If Jenkins gives you so much trouble and you kind of, why not move to GitLab CI completely?
That's what we're doing.
Oh, I thought the end goal is away.
Oh yeah.
Oh, okay.
Oh yeah. I'm excising Jenkins from the whole code base. It's not coming back. Yeah. Yeah.
And as an GitLab employee, thank you. We appreciate that.
It does an okay job most of the time. We're relatively happy with it.
You mentioned in your monolith and you mentioned about microservices.
So we're trying to like hit a sweet spot between being a monolith and allowing microservice use. And so a lot of that app stuff I was talking about with very strict folder names tries to make it so working inside of the mono repos, like working on your own microservice. But the long answer is no.
But Eric's, we're not really a monolith. We're mono, right? I mean, so we have a monolithic aspect of it, most part of it.
Right. So it's a mono repo, not a monolith, but all the code sits in the same place and everyone has to do the same things to interact with it, and teams can't make individual choices. So it does effectively hamper some development speed. So it's somewhere in between the two.
And lastly, which part of Arizona?
Tucson. Love Tucson, man. Beautiful.
Right.
Thank you
Stop
so
sharing,
much.
Harry.
You're doing these back to back, so bio breaks are at the very end. Next up, without further ado, David Bernfeld from tell us about their journey into open source, Cloud Native and open source tickets. So, open source for Cloud Native products.
Did you switch it up?
Hello, you hear me?
Yeah.
Okay. So first of all, apologize in advance. My English isn't as fluent as yours. Okay,
Give me a second.
let's start.
Cute.
Show of hands, how many people here are actively contributors and open source code? Show of hands. Yeah, not too bad, like 40%, I would say. Okay, great. Okay, so my name is David Mortentile. I am team lead and the software developer at Armo. I'm also the maintainer and main contributor of Cubescape. And I also, you can find me on social media. And so what we're going to talk about today is about, first of all, our journey, Armo, from, I would say, from closed source code to towards the open source code. We'll explain why we did it, how we did it, the benefits. We have some tips, maybe to do some, maybe a little bit of what not to do, and also obviously what everyone cares about is if you're all open source. So where's the business model here? So our story begins around 4 years ago as a small startup of two really professional security experts that they started with a great product for securing Windows and VMs. From there, they moved to securing VMs and then and Docker containers, and then they also tried securing Kubernetes clusters. The product itself was a really great product. CISOs loved that product. We had really good technology going on over there. It worked great. The problem was when the CISOs asked their DevOps to install the product, the DevOps did not really, I would say, relate to it. It broke sometimes their backward compatibility because if we were security, we were really security, and it didn't always go the way they wanted it to go. And the moment the DevOps don't want to install, don't want to have a product in the organization, it's just not going to work. So for around 3 years, we were developing this great product, but without much success of selling it. And then one day, we had the NSA. The NSA came out with this. And NSA came out with a Kubernetes hardening guide for security. That means they took out this white paper with many recommendations of how to configure the Kubernetes YAML files, the Kubernetes configuration files. And with when that came out, we had this small little microservice, and our large solution, we had the small microservice which scanned Kubernetes clusters for misconfigurations. So the VP R&D, I was trying to. So it was a Friday morning. The lights in my car went out, stopped working, and I just went onto YouTube. I ordered myself from Amazon a new light bulb for the car, and I said, okay, I'm going to fix this light bulb. I'll figure out how to do it. So while sitting down on this South Korean car, I tried, my hands were all black. He calls me and he's like, hey, there's this NSA thing that came out. Can we take that microservice and turn it into a like a nice CLI tool just for the fun of it? How much time do you think it will take us to do it? I said, let's give it a week for this transaction. So the whole week I worked because I promised him I'm going to do it. So I worked really hard that whole week. And then comes Thursday, I'm sitting with my VP R&D in the same office. He is calling the CEO, telling him that our product is ready. Finally, the CLI tool that we promised is ready. And the CEO says, what CLI tool are you talking about? I asked you to write a blog about that to say, and how we can protect it. So I was frustrated. It was Thursday around 5-6 o'clock p.m. And as you all know, we never delivered to production in those hours. But since I was frustrated, so the VP R&D just said, let's just deliver this repository and let's see what happens. And then we delivered the repository, went back home, and then Sunday morning, or Monday, we start receiving phone calls from people who claim that they are our competitors. And they're asking us, what are you doing? Apparently, this CLI tool went really viral over the weekend. We had over a few hundreds of stars over the weekend without any advertisement. Our marketing team, our marketing person, didn't know anything about it. And it's something from, I would say it this way, we didn't know how to react from a place that we never dealt with open source. Maybe asking questions in Stack Overflow, not more than that. We came to a place where suddenly we have issues in PRs opening, and how do you deal with this? Now, I asked my VP R&D, who has, 30, 40 years of experience as in the field. I said, okay, so what do we do now? Like, how do I respond to all these PRs and issues? And he's like, I don't know, I never did this in the past. So, and here this happened around a year ago, a little bit over a year ago. And this is how our journey to open source began. I would actually skip on this, and here we are today. Today we are almost 40, we're above 40 employees. We raised not long ago $30 million. This is maybe the chance to say this. We're also, if anyone is looking to a place, if anyone wants to join us, you're more than welcome. We have over there some swags, and we also have over there our fax number with near the papers. What? Fax number, yes, right over there. Please feel free to reach out. Cubescape right now, we have almost 7,000 stars. You can see over here the details. It's a great project we're working on, and this is we are right. But let's see who knows. When I tell people that we have an open source product, what are the two most popular questions?
How do you make money? What's the license?
How do you make money? What's the license? That's actually not the most popular question, but that's a good point. It's Apache, by the way. Any other question? Okay, so the other question, actually, a student, first time I heard it was a student that I was interviewing. She asked me, you're a security open source tool. If you're a security company, how are you open source? But we're not going to answer that question now. Anyway, obviously, where do we make the money from? Or I would say that I would rephrase this question as, what's the business? Now, by the way, from my experience, when I talk with people at conferences, etc., so usually Europeans, Americans, also Asians, they would talk with me like for a while, and then they would come to the question, oh, what's the business model over here? Israelis would right away ask me, what's the business model over here? So, exactly.
What did you write about?
So there's the PLG methodology, which is the product-led growth. The idea over here is that you have the developers. That means you develop you develop your product. You have developers who have a certain problem they want to solve. Or I would say the customers, and I would actually bring it as an example in our case, because if we're talking over here of Kubernetes, securing Kubernetes. So their DevOps wants to secure to configure his Kubernetes deployments, etc., the right way. So he would search around the internet to find such a product that would do it for him. He would bump into Kubescape and to also others, but let's say he finds Kubescape in GitHub or wherever it is. He downloads, he runs it for the first time, and he sees, wow, this gives me. This can give me some value, this product. And then he starts playing with it a few times. And then he sees, and then he sees it actually helps him. And then he starts implementing, and he puts it as part of his pipeline, the company, or wherever it is. And then slowly, instead of us searching the CEOs and going to the golf course, playing with them, we have their own DevOps selling for us our product. There are many examples of doing this. Let's say Silk, they do that. The PLG is really popular, and a lot of companies do it. So we moved from a company that's security company. We moved to DevOps first. It means from now on, it's not that we created, oh, this is how security should look, but we first search of what the DevOps like. How the DevOps are expected to see things, and based on that, we know to build for them the correct security. You can go through the different things. I did the slide just because I had to put here Lewis and Ross and Mike. I would say every time when we have new employees in our company, and I want to explain them on our product and how we should develop and what I expect from them. So I was telling them there's a CSC, which is the product must be clear. It also must be simple, but it also must be valuable. If you don't get these three things right, you're wasting your time. It's not. We're not going to move forward with that. This is an example of how our GitHub page looks like. I hope the light isn't bothering us over there. You can see it's pretty simple. You download, you run, you see immediate value. This straightforward. This is a CLI tool which scans a Kubernetes cluster for misconfigurations. You can see over here. This I didn't. This is like based on one of the. This is the NSA framework. It can show you how your cluster is compiled with your compliance with the NSA framework, and it's pretty straightforward. It's like at first glance, you can see the immediate value out of it. We also have we also have the SaaS version, which is also free. And by the way, we're working on open sourcing also our SaaS version, which means that our whole product end to end would be open source. We have also a graph that will show you all the different access role binding, which all the RBUCs in your cluster, and also we scan the image vulnerabilities. So what does it mean to be an open source company? Does it mean that you move your code base from private to public? Well, the answer is obviously yes. I'm kidding. It's also, but it does require some more things. First of all, community. The community is really, really important. The community, I would say, is the most important. It also means that you need a Reddit, a Twitter, a LinkedIn account. You also sometimes TikTok. Depends how old you are, or what are your available your potential customers. The GitHub page. The GitHub page is really important when you talk about open sourcing. You need to know to respond to issues, to respond to PRs. There are discussions over there. A lot of times you have one person opening up an issue. Example, we had a PDF, someone required an exporting of the PDF reports. Now, I don't know why someone would ever want such a thing. I really don't get it, but someone opened the issue of feature request for that. And then we had a different person that also, I have no idea who that person is, who the guy is. He said, hey, why not? I will do it. So we just added a few, like to that PR request, we added some explanation of how you can implement such a thing. And someone else came and developed it for us. So it was great. It saved me 2 days of developing it, but now it's saving me a few. And now I'm wasting a few days for backward compatibility. Yeah. So there are the pluses and minuses over there. We also have what let's say whoever knows over here, Prometheus. Prometheus saw our project. The maintainers of Prometheus, they reached out to us. They asked us to have to implement support of integration with Kubescape and Prometheus. And I didn't really know Prometheus back then, at least I didn't have enough of experience there. So I can say I learned Prometheus from the maintainers themselves. We sat a lot, we sent a lot of videos of examples, etc. And it was a great journey, but it's also something that costs time and a lot of efforts. You must answer quickly and informatively. This is really, really important. We're not the eVTOL community or anything like that. You really need to give good answers, and it must come quickly. Also, working with influencers, this is something that you can't avoid this. You must, I believe, I'm sorry, this is a tip. You should work with influencers. It's like that companies work with models, etc. It's like that Lotem said as the influencer of Discount right now. So working with influencers opens you to a lot of different populations, people in India, people in Europe, etc. It's a really great way of finding those people. Another thing with which a lot of projects, a lot of organizations don't do, which is I think it's a mistake they don't do that. And this is something that I admit we don't do this good enough. It's to create low-hanging fruit features as GitHub issues and to label them as first good issue or open for contribution, etc. These type of things, because there are a lot of students out there who are really good, really bright, who or even people with experience who want to get into the open source community, or that they want to learn a specific language like Go and Kubernetes, and they're looking for first good issues. And this is the way of them. They simply search GitHub for this. And if you have a low hanging fruit, if you explain exactly the requirement of the feature, etc., this can really help. Now, I spoke mainly from the perspective as open source. Now, let's say one word as me as a person, as a software developer, and also as a team. A week ago, I sat with one of the developers in our company, and I asked him he's working already for 3 weeks of a feature on a microservice, and that microservice is still private because he's just started. We're still working on it, and we started to talk about the different the use cases, etc. And then I mentioned to him, like once you complete your POC of this microservice, we're opening it to the public or having it open source. He's like, what? I need another 2 weeks of development over here. A lot of times developers, they think when you know that your signature is in something and that everyone can see the signature, when you go to a job interview or something like that, people would look at how you write code. You think twice before you deliver the code. I can tell that our PRs with our open source code look much better. Also, the reviews, the comments on the review, everything looks much better the moment it's open source. This is from my own personal experience. I can say I develop better when I know it's open source. I pay more attention to this. And this is really important. This is something that a lot of times developers don't notice this, but suddenly you're not only a software developer, you're already a project manager. You're already part of the product. Because once your code is out there, people who come to your company because they want to work by you, they would look a lot of times, they would look at your code, see, do they like the code? Is this company a serious company or is this company not a serious company? And based on that, they decide. Also, after all, this is the face of your company. So thank you very much, everyone. Yeah.
Have you found that the open sourcing of your software to be incredibly beneficial for discovering your business as well?
Sure. We had before that, we would go to conferences and we would explain people. Back then, we were also called Cyber Armo. And we would tell people, yeah, Cyber Armor, and we would explain our product. And now when I go to conferences, people come over and they tell me, oh, I played with Kubescape. This is so cool. Or I think you should, so-and-so, you should improve. But we're in the map. People know us. Okay, thank you very much. What? Yeah. Last question. Yeah, we have also chart, the CubeScape operator. Yeah, it's not an admission controller. I don't know if that was your question, but it's an operator. But you can always ask things in there. We're there.
Got it, fine. What we're talking about unmanaged resources in AWS.
So, hi everyone, I'm Gal Cohen. I'm backend engineer at Firefly. Today I'm going to talk with you about infrastructure as code, what makes it important, and the top unmanaged AWS resources. Firefly is a startup that focuses on a product which is cloud asset management solution. We help DevOps team to manage their cloud, get to know the resources in their cloud, and automatically codify them. So let's start with what is actually IAC. Infrastructure as code are the concept of tools that allows you to manage your infrastructure with configuration files and not manually. Actually, the simple concept of manage infrastructure and resources like you manage any other software with code using GitHub and everything. What is IAC coverage? IAC coverage represents the percentage of cloud resources you have that are managed using by code. This can be using by Terraform, CloudFormation, Pulumi, or any other tool. When we talk about unmanaged asset, we talk about resource that was created manually, which means it's not managed by code. And when we talk about managed asset, it means this resource is managed by code, which means it has a code of configuration that represents the state of the resource. Ideally, we would like to strive for a 100% of IAC coverage. Here we can see a graph from a Firefly application. This is of one of our customers that represents their IAC coverage. You can see the green part represents all their managed assets, and the red one represents the unmanaged assets, which means they were created manually. Why do we need 100% of IAC coverage? So the first thing is when we work with code to manage our cloud, we have a low risk of human errors. If any one of you created a resource with AWS, you probably noticed there are a lot of checkboxes there and a lot of configuration. You need to figure out what each configuration means, and it's very easy to miss out when you configure it manually. Another thing is working with infrastructure as code, make your environment much more immutability and consistent. So when you create code to represent your infrastructure, you actually create a blueprint of your system, which is it's a constant. It's a blueprint of your environment, which is constant, and it's every change you make with this infrastructure goes over validations and checks. So it helps you to duplicate environments if you want, if you like to create another environment of your system in a different region or a different AWS account. That makes it very, very easy. Any one of you who remember this night when all US East 1 was down, the most popular AWS region, and a lot of systems were down because they're dependent on this region. So if you manage your infrastructure as code, you can create your system in different regions and accounts very, very easily. Another cool thing about infrastructure as code is the ability to add scanning to your CI/CD. Either if you work with GitHub Action or Jenkins, you can add scanning in the process before the code even deployed that will check your configuration. You can add scanners like linter to make sure you're aligned to the best practices. You can add scanners of costs and security. Another thing about managing infrastructure as code is actually that you can have all the advantage of managing with DCS. Like, for example, you can create a pull request. I can add configuration to my system and ask my colleague to add a review on this. This is very powerful and it makes us much better. Another thing is when we have versions of our infrastructure and we can look after it. And actually we have code, which is the documentation of our system, which means if someone new come into your team, he can look at this code and understand which resources you have, how your infrastructure looks like. And that's very cool. All this leads me to the last point, which is the speed. Deploying infrastructure with code is much faster than doing it manually. So, as we work at Firefly, we get to know many of our customers' clouds and patterns that repeat themselves from the smallest company to the biggest one. We get to know a lot of use cases and things that companies miss out. And today I chose the top 4 unmanaged AWS resources that are very, very important, and we found that tend to be unmanaged most of the time. So the first resource is Route 53 DNS records, which is known with his tendency to be destructive. We all remember that Facebook was down because of DNS. That's let us know that even the most robust and powerful system can be down due to error in the DNS. That makes it a very sensitive resource, and we need to manage it carefully. And that's why it's very recommended to manage it by code and make all the validation and checks you want to have about it before it's deployed. So the second resource is actually common resources of IAM, roles, user and policies. When companies becomes bigger and they grow, they have more and more of these resources. And sometimes it's become very hard to manage it and to know which access each user and role has and which policy is attached to any of them. So one cool tool we found very helpful with this is OPA. OPA is the Open Policy Agent. It's an open source tool to combat policy as code. Actually, in OPA, you create a policy, you can run it on any data you want and get the response if the data matches policy or not. So we use OPA to run policies on resources configurations. And therefore, we get to know very important insights on our resources very easily. For example, one policy we have is policy that returns a list of all the users that doesn't configure multi-factor authentication. If you're trying to get this list manually, it can take time and you need to go over at each user and look for this attribute and if it's configured or not. By using OPA, you define the policy once and you can run it on a big list of data and get the results in 1 second. So this is very powerful and we find it very helpful for us and for our customers. So this unmanaged resource is S3 bucket configuration, one of the most commonly used AWS services. This is the storage service of AWS. And we found that it's still often unmanaged and people tend to create it manually. The thing about S3 bucket is we have a huge variety of policies we can enforce on bucket. Here I put a few policies we can ensure in our bucket, and these policies are very powerful. But because we have so many configurations, people tend to create the bucket manually and go over all of this and just create the most simple one. Also, this resource is very, very important. In many companies, their architecture is based on the data in the S3 bucket. Most of the time, this is sensitive data of our customers or data that we need in our systems. So this makes this resource very, very important, and we need to ensure policies about it. Another cool thing about infrastructure as code is that you don't need to repeat yourself. For example, in Firefly, we create a model of bucket. On this model, we configure once all the policies we want to ensure on our bucket. We define the public access of the bucket. We define which users and group have permissions, and we define the life cycle. Every configuration that we define as standard. And each time we create bucket, we use the same model. And this way, we don't need to repeat ourselves. We create this model once, we decide which configurations are the most important for us. And the next time we create bucket, we don't even need to think about it, and we don't need to do anything, and we get it out of the box. Our last resource is KMS, Key Management Service, the service that AWS used to encrypt data. It's used in many other AWS services, for example, to encrypt data in buckets, to encrypt data in Dynamo table. That makes this resource very, very important because we always want to protect our data, our customers' data. And when system grows and become bigger and scale, sometimes we have multi-keys and it becomes very complex to manage. When you manage it with code, you can manage all your keys in one file. You can arrange it in the way you find it helpful for you, to arrange it, to split it to the services or to the relevant components. And it makes it much easier to manage. So we talked about what is ISP, what is ISP coverage, the top for unmanaged AWS resources, and I want to tell you about some tips from Firefly. We have to get to 100% of ISP coverage. The first one is full cloud visibility. It's very, very important to get to know your resources in your cloud and get to know your environment in order to create code that will be efficient and will be easy to work with in the long term. So if we know our internal processes, we know how our infrastructure is working, and when we can create the models according to this, and we can create the struct of the code that will be fit and customized to our use. Another thing is codify the legacy environment. For some companies, in many companies, we have resources that are created even before infrastructure as code was the common way to deploy resources. We can't forget these resources because before infrastructure as code exists, companies were redeploying the resources manually. Each company adopted their special process of scripts and manual process to deploy resources. When infrastructure as code become the popular way to manage resources, they adopted infrastructure as code, but they still have their legacy resources that are managed manually. This makes managing your cloud much more complex, which is already complex. So we really recommend to start moving your most critical services to code. Another thing is monitor for drifts. Drift is a case when the configuration in the code doesn't match the configuration that actually running in the resource, which means maybe someone changed the resource configuration manually. Maybe you have a CSPM in your cloud that update your configuration. But at the bottom line, the running configuration is not the configuration you define in your code. That might make your environment unpredictable, and we should avoid drifts. So the last one is just don't forget the forgettable resources. I hope we can learn from other mistakes and do better. Thank you all for listening and for your time. You can ask me anything you want, and you can try Up.Go Firefly. It's free. Thank you again.
Always DNS. Segue. Any questions? Wow, yeah, you can have a question. There's a question. Don't.
Oh,
All right, also hands up.
So two things. One is, do you support crossplay? And the other question is, how do you treat resources that are created from things like, say, Kubernetes and innovations, like Kubernetes implementation and stuff?
So we don't support crossplay yet. And when resources are created by auto-scaling, for example, at Firefly, we represent these resources as children of another resources. And that's make them managed because their father resource is managed by Cloud, and he created this sub-resource. Yuval here can tell you a lot about it.
Are you writing and maintaining Rego code for an open policy agent like enforcement, or how are you using OPA?
Yeah, we use Rego code. At Firefly, we create like I think 60 policies. We give our customers out of the box; they can use them, and we help them to use the Rego code to create policies that fit to them, their cloud, and their needs.
Definitely awesome folks. Want to say a few words to that?
רק שתיקחו בסוף פרקים קטנים, דברים שצריך לעשות בהקדמה, ותודה שהגעתם לכבוד.
Yes, definitely come support the Ziprecruiter events, and Ziprecruiter are always hiring, right? Join Ziprecruiter.
We're looking for an SRE, do you know any?
Definitely, you'd want to work in this office. I don't work in this office.